or good afternoon. I'm here to tell you about what you'll be doing in math class today. You need this packet, so you'll be completing your warm-up on your own. You have a page of notes that I will be going through with you in a few moments. You have your classwork, which front and back you're going to complete and turn in. It's not many problems, so I'm sure you'll be able to finish it if you are actually working during today's class. And finally, you have your homework. You are going to take your homework out of this packet by detaching it from the staple, because you are going to need to put this homework page into your binder so that you can take it home and do it at home. You can also turn in the homework that is due today along with your packet. But when you turn your packet in, you should not have the homework that's due on February 16th in the packet. And ideally, you also should take out your notes so that you can put those into your ISN. So what you're turning in to me today is the Math Minute and the classwork, and that will be for a grade. Also, since you are watching this video, you can be entered into a contest to win a pack of stickers and a homework pass if you email me the following secret phrase. Koalas are cuddly. If you email me that phrase, you will be entered into a contest to win a homework pass and a sticker pack. Okay, so briefly, I am going to go through these notes with you here about the different features and vocabulary for a parabola. So we are going to start with a word that you already know, which is vertex, which is the place where the graph turns around. You name it as a point, so when you talk about the vertex, you talk about it as a coordinate. Find the vertex on this parabola and put a dot on it. If you did it correctly, your dot should be right here. So this parabola has a vertex of 4, -2. So on the graph above, we're going to fill in 4, -2, because that is the vertex. The next is maximum or minimum. You say whether your vertex is the highest point on the graph, which means it's a maximum, or the lowest point on the graph, which means it's a minimum. Think about whether this point would be the highest, which is a maximum, or the lowest, which is a minimum. That's right, it's the lowest point, which is a minimum. Okay, next is the equation. So you use your vertex to determine h and k. If it's upside down, you put a negative out front. So of all of the parts of these notes that are new for you to learn today, this is the part of class where I teach you the thing. The equation is the new part of today's class. So look at your vertex. This value is going to be h, the x value, and the y value is going to be k. So I know in vertex form, and you can go back to your notes from before, it's y equals a times x minus h squared plus k. So what you're going to do is plug in h, k, and a based on where your vertex is. The only thing you need to worry about for a right now is whether or not it's upside down. This graph is right side up, like a smile. So a, you don't actually need to worry about. I also noticed that the vertex of my problem moved to the right 4. So h is 4, and I fill in x minus 4 squared right there. For k, I just look at the y value of my vertex. You can also see that it went down 2. That's 3. Oh my gosh, I'm so sorry, guys. Were you thinking that the whole time? Were you like, Miss Lunsford, that's 3? It's hard to see through my little camera screen. That's not really an excuse. But yeah, this is definitely -3. Look at that. It's clearly -3. What was I thinking? Either way, this is -3. Okay, so you could put plus -3 or -3. So this part is h, this part is k, and you just plug it in. If for some reason this was a negative number, you could write minus negative, or you would just turn it into a plus, because minus and negative is plus. Okay, your line of symmetry is the line that cuts the graph in half. We talked about this last time. And it's a vertical line just like this. Traditionally, we do it with dashes. So it looks like that. And if you are interested in the equation of that line, you notice they all have the same x coordinate, which in this case is 4. So the equation is x equals 4. Another way that you could notice that is that it's always x equals h, which is the x coordinate of your vertex. Okay, last is domain and range, and we've talked about that so many times. Your domain for your parabola is all of the x values, and since it's going forever this way and forever that way, whenever you're finding the domain of a quadratic, it's always all real numbers. You could also say negative infinity to positive infinity like that, but it might be easier just to put the R shape. And finally, for your range, you're going to find your lowest y value and your highest y value. One of them is always going to be infinite. So my lowest y value here is -3. And then it's going to go up to infinity. One thing I didn't put on your notes is that it's always going to either be k to infinity or -infinity to k, which is the y value of your vertex. And we'll talk about this more. But basically, the x value of your vertex helps you find the line of symmetry and is in your equation. And the y value helps you find your range and is also in your equation. You can pause the video here to write any of this down if you missed it. And of course, I'll be back next class to explain this further. But hopefully, based on last class, you have a good idea. If the equation is a little bit challenging for you to find, just remember you're plugging in h and k, and if it's negative, you put a negative out front. That's pretty much it.